All right, so we're going to talk about the water quality of our estuary. Now, estuaries are places where freshwater and saltwater mix. Obviously, the Gulf of Mexico is our saltwater source. And then behind us here, we have a state park called Warner Boyce Salt Springs State Park. I've talked about the springs in some of my other videos. These springs are pumping fresh water or slightly brackish water into the estuary, and that causes an influence of the chemistry of our water. So we get about every 6.5 hours a tide change, and so the ambient or the abiotic factors out here can change a lot. One of the best ways to look at the health of our ecosystem out here is to look at the water chemistry. And so we use Veneer probeware. This is a Veneer LabQuest, and I have some different probes attached to that. We look at 5 parameters per day out here to determine whether or not it's a healthy habitat. And so each of these have what we call the optimal range, tolerant, and then the intolerant range. So fish prefer to be in the optimal ranges, and we'll discuss each of those a little bit in more detail. One that is really important is temperature. Temperature can greatly affect the activity of the fish, whether or not they're seeking out sunlight or shade, depending on winter or summer. But it also affects our dissolved oxygen. So dissolved oxygen is the amount of oxygen that's in the water for the organisms that live in our estuary. And so dissolved oxygen is going to be added to the water. It diffuses by just the air, but waves, and it also can be depleted by microorganisms. So the more organic leaf matter, or what we call detritus out here, the more active the microorganisms that are decomposing that stuff is going to be, and they're going to be lowering the amount of oxygen that's available for the fish in that habitat. So we like anywhere around 7 to 8 milligrams per liter to be a really good habitat for dissolved oxygen. We also measure salinity. Now, we're in an estuary. Estuaries are where freshwater and saltwater meet. We have rivers to my right over here, just south of us, which is called the Cody River, or the Pithalachas Cody River. And we also have springs directly behind me from the Warner Boyce Salt Springs State Park. And then directly to our west, we have the Gulf of Mexico. And so these are going to be greatly influencing the amount of salinity in our water. And so at high tides, we have higher salinity. At low tides, the springs, the rivers are pushing out some of that salt water, and we get lower salinity. So on average, we get about 18 parts per thousand in the estuary daily here. But that does fluctuate with the hydrological cycle. So as we're coming out now in May towards our wet season, our salinity levels will start to drop, but we also do get higher tides. So you get really these wide ranges in salinity during the summer months. And then when you get into the winter months, it's drier, and the springs aren't pumping as much, the river's not flowing as much, and we can have pretty stable salinity at those times. One of the other tests that we do is pH. So we use a pH meter to determine the acidity or how basic the water is. And so the pH scale goes from 0 to 14, 7 being neutral. And fish, we say they like it anywhere between 6 and 8 is great. All right. So that's what we're going to be looking for today with these 4 probes. And then I'll do another video about turbidity. Now, turbidity is the amount of suspended solids that are in the water. So you might have tannins, you might have algae, silts, sands, things that are getting kicked up. Algae is a big problem, blocks out a lot of the sunlight at the surface and doesn't allow it to get to the plants like our seagrasses here in our estuary. All right, so when you get your water sample, you're gonna wanna go down to the water. You wanna go in slowly so that you're not kicking up any of that sediment that's on the bottom. And you wanna try to clean out your bucket as best possible so that we're not getting any residuals from the day prior. So you take some water, pour it out, and then go to a new area, and you'll dip your bucket into the water slowly. You don't want to go down against the bottom, but just get yourself a nice sample, and then you're going to bring that back up and test that water immediately, because we don't want any influences like the sun changing the temperature. So you want to do it as close to the sampling time and get those readings as soon as possible. All right, so the system is active and all the probes are being recognized right now. And I'll try to hold this as close to the screen as possible. The sunlight's probably not helping me here, but you'll see that there are recordings. Now there's only 3 ports on this version of the LabQuest. LabQuest 1 is the LabQuest 2. So you can only do 3 readings at a time. The LabQuest 1, you can do up to 4 readings. And so we usually give students their own LabQuest and 1 probe per, so that we don't have to wait and get those readings. All right, so been about 30 seconds for our temperature, and today we're at 21 degrees Celsius. And so I'll give you a comparison in Fahrenheit for that. Dissolved oxygen, we want to be around 7 to 8 milligrams per liter. That's the optimal dissolved oxygen. Now, temperature affects how much saturation water can have as far as dissolved oxygen. The warmer the water, the less oxygen it can have. The cooler the water, the more saturation it's going to have. So at this temperature, 8 milligrams per liter is going to be about 100% saturation, which you can't get any better than that. And today we are at about 7.85. So we're probably in the 90% of saturation. I also have our pH or our salinity probe in here, and our salinity, I said, on average is about 18. We're at an intermediate tide right now with an incoming high tide, and we're at 18.6. At low tide, you can get down in the lower teens. During the real wet season, September, usually we get readings single digit. But again, it fluctuates. All right, so the final probe that we're going to do is the pH probe. Now the pH probe has a storage solution. It's just distilled water. You want to set that off to the side. It just keeps this little membrane wet and doesn't let it dry out. So I'm going to remove one of our probes and attach pH. And so pH, on average, we get about 7, which is neutral, and that's ideal, the most optimal pH range for the widest variety of fish and organisms. And so 6 to 8 is what we're looking for. And again, you want to wait about 30 seconds. And so today we are at 7.05. So perfect. You can't get much better than that. The last test we're going to do is turbidity. We have what's called a turbidity probe here. And if you look down at the bottom of the barrel there, you're going to see this little black and white checkered disc. And so turbidity is the amount of suspended solids. It's going to be the clarity of the water, how murky or clear it is. And what we do is we pour water into the tube here until we can no longer look through and see that black and white checkered disc at the bottom. So I'm going to attempt to do that here by pouring water. So you want to go up as high as possible, let those bubbles settle out. Another thing, if you're in the sun, you want to make sure that your back is casting a shadow over the turbidity tube. This is to release the water, and so as you're releasing it, you're going to be looking and observing down into the tube until you can start to differentiate between the black and the white of that checkered disc. As soon as you do, you want to cap that off and you want to measure on the side here. And so we measure in what's called the nephelometric turbidity units, the NT units, and this is going to be used in a conversion chart to get us that NTU value. So I'm going to start releasing the water. And this can take up to several minutes to drain until you do. So obviously the higher the column of the water is, the clearer it's going to be. The lower it has to go, the more suspended solids. Some of the different suspended solids that you might have in the water are going to be algae. And during the summer months, we get lots of tannins from the leaves that are falling in. Same process of making tea. Warm water steeps out those tannins from the tea leaves and then allows for you to see that. So right now I can just barely make it out, and so we're at 45 centimeters, and I'm going to take you over to the conversion chart and show you what that means in NTUs.
All right, so every day we record these. We have over 288 recordings, and the students use an iPad to submit it. We have the monthly averages, but we also break it down into a yearly average. And so you can see all of our parameters are optimal for the conditions for healthy environment.